Hi guys, welcome back. This is the 6th episode of our DevOps learning series. Today we'll be discussing about orchestration with Kubernetes. If you have missed any of our previous episodes, you can check out the link above. If you want to learn DevOps and get globally recognized certificates, you can check out our DevOps course. The link is given below in the description box. Let's start the video now. Alright, so far in the previous sessions, we talked about Docker containers, where we discussed about what is container, what is the container technologies, how do you deploy the containers, what is the need of the containers, what it brings better than the legacy OS systems, right? But now in this session, we'll be talking about how do you manage the containers, how do you orchestrate the containers systems. So for that, whenever we say orchestration, the Kubernetes is the term which comes in the mind, right? So Kubernetes in these days have been totally spread across all the spatial IT companies where they have been using the container technologies, and mostly everybody is using container these days to deploy their applications, to have a microservices based architectures where the applications are typically not linked to each other, but they are linked in a way, right? So it's like a lightweight systems to have it. So to maintain those containers that we have spoke about, Kubernetes is the term which basically deals with it. So if you look at how do we manage it, what is the advantages of being using orchestration tool, we will be discussing that. So we write it Kubernetes as a K at S, which symbol as a Kubernetes. Okay, yeah, so this Kubernetes basically it's nothing but an orchestration tool. It's kind of have a mechanism where it manages the containers. How do you make sure the container is up and running? How do your services is up and running? So if we see that it let containers to self-heal, so it gives you that facility to self-heal the containers. Then you can have multi-container applications that we spoke about. How do you manage the multi-container applications, that the application should be up and running, and how do you manage those? So for that also you need Kubernetes, that it can help you without manual interventions, with the automated way to manage those multi-containers applications or apps. Then it can give you portability for if we talk about to the across systems, portabilities across clouds and on premises. So you can have, let's say, AWS, you can have GCP, you can have Azure. So you can have any cloud, or if you want to have, you can have on premises also. So it gives you that portability that you can interact the containers within any of the cloud sort of a thing. So that also can be managed by the Kubernetes as a platform. So it's an orchestration platform which manages and self-heal the containers and let you manage it its own way. Now let's talk about some key components of the Kubernetes. So we see that what Kubernetes is. Kubernetes.io is the public website of Kubernetes, where you can just read through all the documentations of Kubernetes, what all components it supports and what all components it offers, how does the individual components work actually, and then if you want to read more about how do you deploy it, the hands-on, everything is there on this documentation actually. So if you look at this Kubernetes components, you see that in this diagram, if I just make it big. So this is the control plane that you see in the left side. So control plane, and then other side we have a cloud provider APIs. Then we have nodes. So think like that, these nodes are nothing but the compute nodes basically, which has a CPU and a memory to perform. So these are those nodes. So it can be stack servers where the compute nodes are there. Like for example, if we talk about AWS EC2 machines are the compute nodes, where it has performance of CPU as well as the memory that it can offer for any program or any process to perform. So these nodes, on these nodes we have a control plane. So control plane is also being deployed on a node itself only, but control plane is like a architectural way to individual components to manage it actually. So what all it has, it has a controller manager, it has a etcd, which is a another storage persistent storage to manage things. How does it do? Then it has a kubelet and then kube proxies and schedulers to schedule like a cron jobs to make sure everything is whatever has been scheduled for, it should perform its own job. And then to communicate these clusters individually with each components, it requires provider APIs to have it. So everything is being deployed on this node. So if you want to read through about what is Kube API server at CD, so all these definitions are available in the kubernetes.io docs. So you can just read through that. For here, I'm just trying to explain you that it has all sort of technologies in place, like whatever is required. Networking is required to communicate. DNS is required to have an internet name server resolutions, or in order to intercommunications, they have a proxies also. They have they have IP address linking also. They have a lot of stuff that Kubernetes itself provides. So it's like a very vast topic to discuss about, but yeah, you can go through this, and then if you want to read more about what individual component does, so you can just go through that component, and then it will let you access those things. So this is kind of good in a way to read through that. So individual component has its own ways, like which manages. So the overall view or objective, if we say, so these components helps to manage your container orchestration. So it manages the container. If you have, let's say, hundreds of containers running on a machine, how do you manage those containers, and how do you make sure that containers are up and running? The services which are very preliminary important for anything to serve to the customers or to the consumers, it should be up and running. So to manage those, to make sure on a regular basis you do a health checkups or a test runs to make sure the services are up and running. So that all things will be as a bundled or a package of what Kubernetes offers us in a way. Now, if we talk about the demonstration of the Kubernetes, right? So you can do that. There are multiple tools that are available. We'll be using Minikube here. So if you Google it up, Minikube, you will get the idea about what Minikube is. It's kind of in a short way of what Kubernetes offers. So it will be like a local Kubernetes that you can deploy on your machine, but it has some prereqs, without 2 CPU of CPU and 2 GB of memory and 20 gigs of free space should be there, internet connection, in order to make orchestration tool live. And to have a container, you should have Docker or QEMU or HyperKit and Hyper-V. So you need some sort of a layer of orchestration of the containers. Without that, it will not work under the hood. So, and then installation guide is present for the Minikube. So I followed this instruction guide for MacBook, and I was able to download and install Minikube, and it is currently running on my machine. There is one more utility that I downloaded, is kubectl. So kubectl is nothing but a controlling services. It's like a small utility which can leverage the Kubernetes clusters, operate the Kubernetes clusters to see the components which are in what state. So kubectl is pretty much required for that. So I have downloaded that as well. And then let's look at the demo directly just to understand, what basically it has it. Okay, so this is currently I am in the Minikube directory, where I have created all the files which are required in order to perform the Kubernetes. We'll see individual components, what all things are very much important here. Okay, so first of all, let's review the Minikube status. So Minikube status can give you an idea about that my Kubernetes local Kubernetes tool. This is a control plane type. If it is running or not, it is currently in the running space, running state. Then kubelet also is running, and then API server is also running. So I am fully ready to perform the Kubernetes on my containers, right? So it's currently live for me. All right. So now if I would want to deploy or create things, so very minimal. If I talk about the smallest unit of the Kubernetes is pods. We call the units as a pod. If I go and explain like this, okay, so we have something called pods. This is the minimalistic unit of the Kubernetes, but inside pods we use containers. Just think like that. Okay, so containers are the minimalist unit, but if we talk about in terms of Kubernetes, the pod becomes the minimalistic, the very much to the granular level, right? So what is the minimal unit of anything, like what it can have it. So pods are something on which you can deploy containers and then your applications as the form of containers. So it's a minimum unit of Kubernetes. Then we have something called deployments. So deployments are nothing but like you can just think like set of pods. So you can have multiple pods inside a deployment, and then if you want 3 pods, if you want 4 pods all the time, in one go, if you want to start that, so you can have a replica, and you can change that replica settings also. Replica means like number of replications of those pod units. So you can have replica 4, 5, 3, 2, whatever number you can give. So these many replicas will be automatically being created. So that is what the deployment is. Then replica set is also one more thing. Then we have stateful sets. So these are all. Then we have nodes also, we can see in the Kubernetes. Okay. Then we have services also. So we will discuss a few of them just to analyze and just to understand what it is actually. So first of all, I will show you what is a pod and how does it look like. So in order to create a pod, you need to you can create it live also, or you can create it via YAML file. So I'll be creating it with the YAML file. So here I am saying that API version I want to use is v1. Okay. What kind of a unit, what kind of object this is a pod kind of an object in my Kubernetes. Okay. If I talk about the metadata, means the data about information about my pod. So I have labeled my pod. Labeling is like just to label something. So I have a label called app my pod, and then and the pod name is also my pod. After that I have a spec is like a specifications of what kind of a container that you would want to run. So inside this pod I am having a container with image engine X. As we have seen in the previous sessions that we have used Ubuntu, we have used some Flask applications, we have used some databases to deploy the containers, and also have a multi container applications, right? So in this case, we are having a single container, though you can have multiple containers also in a single pod. But in this case, we are having single containers. Okay, this container will be of Nginx, and the container port is 80. Okay, and how do you create that? So for that, you have to use kubectl. Okay, apply. -f is just to pass on the file, and then you say pod.yaml. So it says that my pod unchanged. Unchanged means it was already running. So if I say kubectl get pods, so it says since my pod was already running from last 23 hours, that's why I did not create any other pod. If it was not running, then it would have been automatically being created here. Okay. Similarly, if we talk about if we talk about the logs of this, so you can get with kubectl logs. So this is the log of my container. So it will explain me so this is required when you want to troubleshoot your application which is running under the container systems, right? How do you do that? Without logs, it's very hard to identify what is the problem occurring. So with logs, it can help us if we don't see any let's say some other error is coming, let's say in this case no such file or directory, something, if it is doing something, so we can get the errors and we can try to understand, okay, something is not going right or something is wrong here. So in order to troubleshoot that, logs is very helpful. You should know how to fetch the logs for a pod. So kubectl logs command can do the job. It can find the logs for you. Let's look at the deployment then. So deployment is another object in the Kubernetes. So it says what kind of an object this is. This is a deployment, and you don't have to remember how to write this file, because in Kubernetes, if you search in the documentation, right? If you let's say pods, so it will lead you to that pod page, and it has a sample file, so you don't have to remember and memorize like how does a file look like. So this explain here how do you create a pod, and a sample file of a pod, and if you want to have a multi-container pod, so how can you do that as well, and then what are the pod controllers and stuff. So it will explain everything here. It has all these details that inside a container, if you want to have a script, so you can execute like this. So this is also an restart policy on failure. So whenever this will fail, automatically it will restart with the help of this option. So it has all the details in this documentation, so you don't have to everything memorize. I'm just trying to explain the way simplified to use, so that you should have an idea about how do we use those objects, how do we create those objects. Later you can customize the object a definition file, and then you can create based on your own things. Okay. So far we discussed about the containers, right? And now we are talking about the pods and deployments, where the container is the minimalistic unit, but though it's part of the pod only, it's part of the deployments only. So in the deployments object, we see 3 replicas. So which means that it will create 3 pods for me. It's like a 3 replica sets replicas I have given it to it, and it is matching a selector labeling which says that it will match for that pod which is having a label called app, my app, and then metadata label also, and then spec is like again what container kind of information that you would want to pass on in the form of pod, so you can pass it up there. Similarly for deployment also, you can create same thing. Okay, and then if you say get deployment, so kubectl get deployments, it will give you, this is my deployment called my hyphen deployment, and currently it's up to date, which means that I wanted 3 replicas and it is having 3 replicas available. And if you kubectl get pods, if you see like this, so there are currently 4 pods running. Okay, one is so whenever you create a pod with the help of deployment, so the deployment name will automatically get attached to it, and then it will generate a random name for the containers, and then this is the pod. So this is another like a pod kind of a thing, but it's in the form of deployments. You can have multiple pods in one go, so that's why we use deployment as a unit. And if you see this one, this got once restarted also. There might be some problem has happened to this deployment, that's why it got restarted. Otherwise everything is just running from the day it was supposed to run, so it did not restart after that, since we already have a settings that whenever the pod or deployment gets stopped, it should automatically restart, so that is how it is. Okay, after deployment we will talk about services. Okay, also if let's say if in case you want to increase the replica size, then how do you do that for the pods? So you can just increase the deployment replicas by giving an option called hyphen replicas, and then number of replicas if you want to increase those replicas for the deployment. So if as soon as I do this, and if you see get deployment, so it says currently 3 pods are ready out of 5, because I have increased the replica to 5. And if I say get pods, so you will see now 5 will be there. Earlier 3 was showing, and out of which these 2 are just created 12 seconds ago, because we increased the replica size. If I again reduce the replica to 2, and then you check it, so automatically these 2 will be deleted. Like any 2 can be deleted, right? So now we have only 2 deployments and 1 pod is present at this moment. So you can just play around with that replicas, and this also you can get it here. If I say deployments, so if you click here, you will it will lead you to the deployments page, and then it will talk about the replica sets and what are the use cases of a deployment, and how do you do that, and how do you increase the replicas. It will give you all these options. How do you scale out and scale down also, so you can get that everything. Okay, so all these options are available. So I'm just talking about in the basic form, but there are multiple other options that you can play around with the kubectl command to play around with the replica sets, or things like those. But yeah, like in a form you can just go through. So currently there are 2 replicas that we have explicitly marked for it. That's why replica sets are 2 at this moment. So yeah, you can just go through each of them and then try to understand what it does and what kind of a thing it performs. So this is helpful for a scenario where let's say some changes has to happen. So it's always recommendable to have a multiple instances of an application, because what if the one instance goes down, so automatically the user request should be forwarded to the another one, right? So that is kind of a good to have the load balancing scenarios where just to manage the load of an application by with the help of fire replicas. And when you think like, oh, the application will not be able to handle so much of a load of the consumer side, so anytime you can increase the replica. So this is a use case, and this kind of a facility can be driven with the help of replica sets of the deployment in the form of Kubernetes orchestration tool. So this is the facility that it provides, and it becomes it makes it very easy to manage those applications. Just think like, when there is no Kubernetes, you don't have a direct way to increase the replicas. So in that case, you are gonna just manually increase the replicas in that case. So that is gonna be tedious at times. Just go to the AWS and then increase the replicas and those things. Even though under the hood they are anyways using the instances of any of the cloud or on premises, but overall it's easy from the outside just to manage those things rather than just all the time going to the backend manual side and then increase those things. So yeah, so that's why it's kind of an easy to manage the resources with the help of Kubernetes orchestration. Okay, so kubectl is the command which can control and manage those Kubernetes objects for you. Right. Now we will be talking about services. Services plays a very major role here. If we see the documentation, you should have understanding about what services are actually and how do you. So if you think like a name of service, which means that it is serving something, right? So it's like in order to communicate or in order to access anything, you can have a services to be created, right? So there are multiple types of services are available in the Kubernetes. And how do you define a service? It is giving an example as well to you. So here I already have a service.yaml file where I'm creating this object as a my service. Okay, and this is selecting this application pod. See, what does it mean that see, any service to perform, so it should also reflect that on which pod it is basically serving something. If it is, there is any pod which is of an application pod, now you want to create a web URL for that application. Just think like that. How do you do that? For that you need a service, but to service to link to that pod to your real application, you need some sort of a mechanism. That's where this labeling or selectors comes into the picture, that this service will only select for those objects, those pods which belongs to whatever the condition of selector has been given, which means that here in this case it will only pick for the pod which is using this label called app, and the value is my-pod. So any pod which has this label, this service will automatically get linked to it. So if there is any code which is any web application that you want to host, with the help of type of a service you can create, and then later you can utilize those. So this is the type of a service called node port. We'll be seeing the difference between node port and cluster IPs and load balancers later, but this type of a service is node port service. Basically, and then this is the node port of the service. I want to export this as a just to on that port so that I can access the internal container target port. So for that I am creating a service called node port. So if you want to expose the port of any pod or any node, you can use node port type of service. So to create that, let's see service.yaml. Okay, now once you do that, then you can see kubectl get services and my -service. Okay, so this is the service that I have, and this is a node port type of service, which means that I am exposing the port of this node. If I say kubectl get nodes, So I only have one node at this moment for this Minikube cluster. Usually there are multiple nodes, because definitely you would want to have a multiple nodes, because if one node goes down, so you should have a backup of serving the objective of your product to the multiple, with the help of multiple nodes. But since we just wanted to show the demo here, so I just deployed a cluster of single node. I can also have a multiple node, so it's like based on the use cases, but for the demo purpose this works fine, so you don't need multiple nodes to have it. But yeah, you can anyways use this. So this same node I'm using for control plane also, and same node I'm using for other operations like other objects also. I'm using for the same node. And if you want to see in the wide format, you can anytime use option -o wide. It will give you wide information about this cluster. So currently it says internal IP, this is the Ubuntu image which is running, and the Docker version, whatever it is running. So it is explaining that, right? Now let's say kubectl get endpoints. I want to get the endpoint of my service. So this is the endpoint of my service. This is a local IP of my service, and then this is a port 80, because I provided my service to have the containers running on the 80 port. That's what I'm exposing outside to that node. So that is what it is actually explaining, right? Now if I see that I want to explore those services, so how do I do this? So for that you can use command minikube service and my services. So it will basically open up a tunnel for me, and then yes, it is able to load the page of Nginx, which is it should supposed to, because just understand this way. This is the service which is exposing the node port for me. Now how come it is giving you this welcome to Nginx page? So this page is coming somewhere from the Nginx image, because service has a selectors that we have seen before, right? So service has a selector value. Let me show it up again. Service. So service has a selector. It is choosing this pod called my pod, which has a label of app my pod. It will choose that, and whatever this pod has inside the containers, it will host the same. And if you look at our pod configurations, so our pod also have this label called app my pod, and it is having a container of Nginx. That's why since we are unable to access the container port, which is the inside port of the container within the container, but we want to export Nginx running from the container to outside node. So for that we created a service. That is a usage of service. So with the help of that, we are able to create a service, but we are exporting it through our way. So this is the port of our service that it is being used for 54, 820, 825, 828. So if you look at that, get services. Yeah, so this will give you all type of services that is available and what are the ports that is being used here. So this is how you can export the any internal container port you want to expose that in the form of service. You can create a node port type of a service. And if you look at the documentation also of service, so you will get explanation of what node port is all about, so you can read through that. But yeah, in a way I explained that within the container, if you have any port, if you want to expose that port as in the form of that node, you can use node port type of service. Now there is some other service also we have it. We call that cluster IP service. So cluster IP service basically exposes the internal IPs within the cluster. So it is mainly used for within the cluster if we would want to expose that port. So I have configuration here. Cluster IP I just changed. So this will be same IP. This is service actually, but the type will be cluster IP. For node port, the type would be node port type of services. If I create this, since I already have created this, so if I say service minikube service my service cluster IP, okay. So this is the cluster IP. Now if you look at the port number is different, this is different port and this is different port. So it's like internal communications is happening within the cluster. But since the cluster itself is picking up the pod which only has Nginx, that's why you are seeing Nginx image over here, the index.html. So you see this is different and this is different. Now similarly, I also have a load balancer, a load balancer type of a service which is also hosting the same Nginx, but the port number is different if you look at here. So this is the differences, how in terms of managing the cluster IP and node port. And if we talk about the overall differences of our services, so we will be discussing here. So if we talk about cluster IP, so cluster IP type of a service is basically for the internal services. You can just think like, internal services. If you want to expose any internal services, you can use cluster IP services. In the short, I am explaining, if you want to use node port, which means that if you want to expose any port of your node, so you can use node port type of a service. Though the detailed explanation you will find in the documentation of the Kubernetes, but I'm just trying to explain the comparison between all of them. Then there is something called load balancer. So load balancer type of a service basically used to provide the cloud providers load balancers to expose services. So if you have any cloud providers, let's say AWS or GCP or Azure, if you want to expose those providers load balancer as in form of handling the traffic, so in that case you can use load balancer type of a service. There is one more actually called external name, which is mainly used for mapping of your external name services. Okay, so it basically maps a service to an external DNS name. So this is kind of usage of various type of services which are basically present in the Kubernetes orchestration tool. Then if we talk about cluster IP, right? So cluster IP is not accessible outside the cluster because it's only meant for the within the cluster accessibility. However, node port can be accessed outside the cluster because that is how it is exposing the node port which is available for the containers. Okay. Then load balancer also you can use with the help of load balancer IP. Externally, you can access the load balancer services. Okay. And then the external name services can be directly use the DNS names to provide for an external, services. Yeah. And if we talk about the use cases when it comes in order to use the cluster IP, so cluster IPs are basically within the cluster communication. So let's say we have a cluster of 3 nodes, and if you want to communicate each node to each other, so in that case you can use cluster IP type of a service. And if you want to, without a load balancer, if you want to expose any port outside world, so you can use node ports type of service. But with the help of load balancer, it can be more kind of a load balancer things where you can just leverage your load to the multiple nodes basically just to have your service be available. So for that you can use load balancer. And external name is just for the naming services to have external DNS to configure about. And in detail configurations you can just read through that and it will give you all sort of explanation that what each service is doing. In detail you can just read through that and understand about, okay, this is how this service is working and whenever it is required. So you should have an understanding about when we say as a DevOps engineer, somebody who is managing the Kubernetes orchestration tool should be aware about what functionality of each services are. Not necessarily important that you should know the each configurations and how to memorize, and there is no need of it, but you should have an idea about what each component does. And whenever it's, because see, every company, they are already being built up with the Kubernetes, they are already using them. So later, either you have to just keep on adding stuffs, or you have to deploy more to that, or make sure that rolling out, or some sort of a scenarios, whatever will come up in the form of patches, that has to be taken care. So you should have an idea about the integrations, in terms of how do you manage the networking, and how do you understand the components of the Kubernetes, so that you can use it. So with the help of this session, can help you at least to understand that idea, the orchestration or the architecture of the Kubernetes, and what do you understand about the various type of components that are present in the Kubernetes form. Now, if we talk about like the basic commands that to describe any services or something, so you can use, there is a command called describe. You can use the to describe any basically any object of the Kubernetes. So you can use describe. Okay, so let's say if I want to describe the services which are currently available, so it says that inside default namespace, this is my service selectors. Okay, what is the IP address and the port number, it is explaining me all that. Okay, and this is another service. So I have three services created. One is load balancer type of a service, one is cluster IP type of a service, and one is node port type of a service. So it is giving me all these ideas about what services I have. If I want to describe, let's say describe pod, my pod, it will describe all the pod that I have currently, what this pod is running. Actually, it's running Nginx machine. It's a Nginx image which is able to pull from the Docker hub, and then where it is actually mounted. Okay, and the volume informations and the conditions. Also, what is the label of my pod and what is the IP address it is running inside my pod container. So you can describe any objects in the Kubernetes environment with the help of kubectl describe command. If you want to delete the pod, let's say, first let me see what all pods I have. Currently I have two deployments and one pod, and I want to delete that. So you can use kubectl delete, and let's say pod. Kubectl delete pod, my pod. So this will delete the pod, and now if I say get pods, it has deleted pod for me. If I want to delete the deployment, my deployment, so now you will not see any pods being created, because the deployments and the pod, everything has been deleted from my Minikube cluster. So this is how you can play around with this. So if we talk about the summary, so you can with the help of Kubernetes, you can list the you can list the objects with the help of get command. You can delete it with the help of delete command. Then we spoke about what is a pod, which is a minimum object unit for the Kubernetes cluster, though it also has a container which is the least very least of object. But yes, the pod is called as a minimalistic the unit of the Kubernetes cluster, where it has the minimal unit of it, right? Then we have a deployments where you can have multiple set of the same pods kind of configurations. When and where required, you can increase the replica, you can decrease the replica. So this will help to whenever the scenario comes to increase or roll out or scale up your system, so that in that case deployments can be a good resource to explore about. Then there are some other resources like services. We spoke about cluster IP services, node port services, load balancer services. Those things we spoke about. Then how do you delete that? With the help of kubectl delete command, you can delete. Then how do you describe each project object? So you can use describe command in the kubectl as an argument to pass on. Then there is a documentation we spoke about. Kubernetes.io can give you any idea about, you don't have to memorize all the time the configurations of it. You can anytime refer the documentations, and it'll give you some hands-on examples, also some idea about what each components, how are they connecting. And if you want to read through about ingress and services and networking like that, so you can go through that, and then He'll give you more detailed explanation about how does the internal networking between the containers work in this scenario. So that is all about Kubernetes for us in this session. All right, thanks for watching. If you have got any questions and concerns, you can drop in the Discord channel. The link is attached in the description below. Till then, keep learning, keep smiling, keep growing.